Europe is in a historic bind. Since the Russian war, the old continent has lost its lifeline, cheap gas. Germany, the industrial engine of Europe, is frantically searching for a way to keep its factories running without destroying the climate. The solution exists, but it is far away, across the Mediterranean. It is green hydrogen, the fuel described as the strategic jewel of clean energy. Egypt, Saudi Arabia, Morocco, and Algeria hold the key. Giant projects like NEOM and the Suez Canal Economic Zone are not just about producing power, they are about redrawing a map of the global economy. But how do we transport the lightest gas in the universe across oceans without it evaporating? And why do scientists call this a challenge harder than the moon landing? To understand the game, you have to know the colors. The world has been producing hydrogen for decades, but it is gray hydrogen, made from natural gas, a process that pollutes the air terribly. Then there is blue, which buries the carbon underground. But what the world wants is green. Theoretically, the equation is simple. Water plus clean electricity equals hydrogen plus oxygen. The problem has always been the cost. Electrolyzers are incredibly expensive. However, the Arab nations have an advantage Germany does not: intense, consistent sunlight and high winds in places like the Gulf of Suez and northern Saudi Arabia. This makes the cost of producing a kilowatt of electricity the cheapest in the world. Consequently, Arab hydrogen becomes a rival to oil. Here we face a complex physical challenge. Hydrogen is a very light gas. To ship it, you must cool it to 253 degrees below 0 Celsius. That is astronomically expensive and commercially impossible at scale. The solution? A smart chemical trick: green ammonia. Hydrogen is combined with nitrogen, found in the air, to become ammonia. Ammonia is a liquid that is easy to transport in standard ships at reasonable temperatures. When the ship arrives at the port of Rotterdam in the Netherlands, they can use the ammonia as fuel directly, or separate it back to extract the hydrogen. This is why Egypt is signing deals to bunker ships with ammonia at the Suez Canal, and Saudi Arabia is building a plant in NEOM to produce 600 tons of hydrogen daily to be exported as ammonia. It is smart packaging for energy. Now, a sharp viewer might ask, hydrogen needs water, and we are in a region with water scarcity. Will we sacrifice drinking water for fuel? Valid question, but the numbers are reassuring. Producing 1 kilogram of hydrogen needs about 9 liters of pure water. In these mega projects, seawater desalination is a core component. The surprise? Desalination consumes a tiny fraction, less than 2% of the project's total energy. So these projects will desalinate seawater using solar power, take what they need for hydrogen, and pump the surplus as drinking water to nearby cities. We are killing 2 birds with 1 stone: energy for Europe and water for the locals. Morocco is planning something even bigger: a direct gas pipeline transporting hydrogen from the Moroccan desert straight into the heart of Europe via Spain. We are witnessing a total reshaping of global trade routes. In the past, the world came to us for fossil fuels that threatened the planet. Today, the world comes to us for the energy of life to save the planet. The question isn't, will hydrogen succeed? The question is, will Europe catch up and prepare its infrastructure to receive the new Arab energy?